All right, good morning and happy Halloween. If you plan to celebrate it tonight, just stay warm if you play the trick or treat, if you still do it. Anyway. Okay, so quick announcement as usual. For your programming test 1, the grade has been released. I will encourage you, if you're not very satisfied with your grade, do make use of my office hour. Come to me and I can retrieve your solution from the lab test. I can go over that with you line by line if necessary. Take advantage of that if you want to. Okay, to get some feedback. I'm going to release the guide for programming test number 2, which will happen next Tuesday. Not the coming one, but next one. And I'll also give you some tips about how you should really get prepared. Most likely, the programming test number 2 is going to be based on a simplified version of your lab number 2. So all you got to do is to redo lab number 2 and make sure you understand the way we do things for lab number 2. Then you should be all right for programming test 2. And for your lab number 3, you don't need to study that for your programming test that's coming. Lab number 3 is going to be about equals method, which we definitely spoke a lot about, and also the copy constructor. We might just be able to talk a little bit about it today, but if not, definitely on Wednesday. So you're definitely ready to do lab 3. Just get started. For your written test number 2, tomorrow, I already confirmed the coverage last week. But yesterday, I just released the guide just to confirm the workflow for the test. There should be no surprise, just like how we ran written test number 1. There were also some practice questions there. I will try to see if I can leave maybe about 10 minutes or so today. I will maybe go over the question with you guys a little bit. So give you guys maybe also some tips for tomorrow. We'll see. Okay, I think that's also important for you. Alrighty, let's now, before I move on, any questions, guys? We okay, right? All right, stay happy. We're getting there. Okay, so today we're going to continue with the call by value. Let me just recap very quickly. So you really want to review yourself this particular slide that's come at first. It might seem pretty abstract, a little bit vague maybe, not very concrete at first. Let me highlight the point you should really know before we go on to the example. So there is this thing called call by value. And call by value will simply occur whenever you have a method call. And the method call has some arguments over here. And the argument value there may be either primitive or reference. Depending on whether it's primitive or reference, things might be done slightly differently, but consistently. That's something you want to watch out for. And what we did last time, if you recall from last Wednesday, very quickly. So if you recall these two examples. So in this case, in the first case, the parameter is simply primitive, in which case we are making R as a separate copy of the argument value, right? Just separate copy. That's in the primitive case. The second case we talk about is when the argument over here, as you can see from the parameter, is a reference type, right? If it is reference type, it's also going to make a copy, but not a copy of the objects, but a copy of the address, right? That's the consistent part. So if you think about this is the arguments, which is an address of these objects. The parameter C over here is going to be just a copy of the same address. And we spoke about in the review lecture, if you make a copy of the address, you're basically creating an alias. That's what you're doing, right? So that's a principle you want to remember. And I'm going to use 3 more examples to just confirm our understanding. And then we're done. We can go on to aggregation composition. Do you guys have any question about the principle of call by value? Any point that's not clear, you can just let me know. Or just interrupt me when we go over an example. All right, let's now talk about the stuff. And if you go back to the slides, for example, we assume very simple class, just point, right? We are pretty familiar with it. We got x and y, we got constructor, we got get x, get y. And also we got these two mutator methods, move vertically and also move horizontally, right? This is what we will need when we do the example. Pretty straightforward, okay? And we're going to talk about 3 different manipulations of the same point class using call by value. Let's take a look. The first one, okay? Question?
Yeah, just so you know, for the call by value, is it pretty much the same concept as the caller and the callee?
In some way, yes. Call by value is really about, if you think about, that's a good question here. If you think about, let's say, this one here, which we spoke about last time. This is indeed where the caller is trying to make a call by passing arguments. And this is where the callee define their parameter. Yes, caller, callee, yes. But you got to understand what the call by value is trying to elaborate is about how things happen from here to here by making a copy, right? Okay, good. All right, let's take a look at the first one. And we have a utility class over here. We got 1, 2, and 3. 3 methods here. We're going to talk about them one by one. The first one would be just this one. Okay, let's take a look. This caller or this method here is going to reassign the integer parameter. You can see we got some integer parameter, so if call by value happen, it's going to be the primitive type case. And here we say j is assigned to j plus 1. That's a very typical thing you guys might do. It is okay, many people do that, but you just need to understand what the consequence is for that one. We'll get there. Okay, just remember that's what we're focusing on. The next example will be the second method. The next example will be the final method. That's a roadmap. Okay, for this one here, let's take a look. I want you to take a look at this JUnit test case. All right, we're going to create some utility object so we can call that reassign integer method. And let's take a look at what the method is trying to assert. We pass I over here, initially 10. And we know that somehow the method that's being called is going to increment the parameter over here by 1. Intuitively, you might think, if I pass 10 over here, it's going to be incremented into 11, right? But it turns out it is not 11 because of call by value. That's something I want to mention right away. But now let's trace deeply to see why. It wouldn't really become from 10 into 11. It remains 10. Let's see. All right, so what we'll do is we're going to create this utility objects, which I'm going to ignore. It's pretty easy to visualize. And we got this integer I. So this will be the arguments, initially 10, right? It's a copy. And asserting that I is simply 10, pretty straightforward. And now we are calling u.reassign int. So we're calling this method over here. And now we want to understand how the call by value is actually going to work. Call by value. You can see argument I and parameter j. Right? So now we'll talk about difference between argument and parameter. Okay? And now let's see. What we said before was j, because the call by value is going to get a copy of I. So what's going to happen is we get a separate copy over here. J, copy of 10, just 10. Separate copies. When you actually want to trace the call of this method here, it's going to be relative to this particular copy, which has nothing to do with the original one. And now, if we try to do, let's say j is assigned to j plus 1, we're only changing this copy from 10 to 11. And it's done. And when we move to the next line, let's say, after this call, we just move to the next one. After the call has been done, I over here remains to be 10. It's only the local parameter over here that has been incremented to 11. So from the caller's point of view, I is never changed. From the caller's point of view, arguments I is not changed. All right, is it clear to everyone? I hope. Anything that's not clear? Okay. And if we move on to another case, which is the parameter being a reference type, things will be done pretty much consistently. Let's see. The second one. For this one here, we're going to talk about this second method here. You can see here the parameter is a reference type, point. And what are we doing there? We simply say we create a new point object locally. And then we reassign Q to be MP. We're also changing the parameter. So now the question is similar question. Now on this particular test over here, and we are trying to call this method over here. You can see this is the argument P. We want to know the P value, the address, before and after. Would it be changed, the address itself? It's pretty much like asking the same question. For this primitive value I, before and after, it hasn't changed. So consistently, the address value P over here before and after, it shouldn't change either. Are we okay with this so far? Okay. And of course, to really convince ourselves, we need to trace it and see what happened. All right, let's take a look. So what I will do is let's trace utility here, just creating it so we can call the method. Let's visualize this P over here. So P is simply just a new point. So P is pointing to a point object, which has X and Y, 3 and 4. That's easy. And just for the assertion purpose, we have some object over here called reference of P before. Okay? That one is simply going to store whatever P is currently. That one there should be obvious. So reference of P before. And it's simply pointing to here. Okay, so far? And now we're going to call that method over here. And we want to know, after calling this method, which try to change the parameter Q to be something else. Is it going to change P, maybe from here into somewhere else, or change this to something else? That's the question. It turns out it wouldn't, but let's see why. Let's step into the method call. Okay, so step into this method call here, and because the call by value, let's now be clear, and we want to know what it means for call by value to take effects. So call by value again, which will focus on creating a copy of P, and then let Q be that copy. Okay, you can see P is over here. What does it really mean to make a copy of P and then make a Q? That means Q is going to store the same address as P. Effectively, it's going to point to the same objects, creating an alias. Let me put a reminder here. A copy of address stored in P, which is the arguments. Right, so far so good, right? And let's now try to trace inside the method. First one would be, let's create a new point, local one. And P is simply pointing to another point objects, which is going to be 6, 8. So point, we got XY, 6, 8. And what does it really mean when we say Q is assigned to MP? That means Q, rather than pointing to over here, is going to point to wherever MP is pointing to. So what we are really changing is not the original P or this one. What we have changed was just the parameter over here into some local objects. Right? Following? Okay. Let me make some remark, and then we'll finish tracing the JUnit test. Okay, you can see Q here is really pointing to here. This is the key point. So this one here, let me make a remark. Only change, only the copy of P is changed. Number one. Number two, P itself is not changed. Because you can see, according to the diagram, P is still pointing to this object. That one is not changed. All right? And after the method call has been executed, we can now assert different things. Number one, P and reference before. P and reference before, still pointing to the same object, pass. And also P.getX, P.getY is still referring to the original object, 3 and 4. So we are OK. So the only thing we have changed was when we call this method here, locally, the parameter Q has been redirected to this. So we are now really doing something very useful. You might be thinking that I can simply change the value of P over here when I call a method. You cannot do it. In another language like a C, you're allowed to maybe change the address directly, but not in Java, not in any OOP language. All right? Guys, any question about this? recap about what we just seen. In the case where the parameter is a reference type, because call by value, we're going to make a copy of the address of the arguments, which is here. Making a copy of it for the parameter, so anything you try to redirect to the parameter itself is only going to change that copy. It's not going to impact the original arguments. It's not. That's the main point. So here comes a follow-up question. The argument over here is pointing to this particular object. Very often, we would like to maybe modify the contents of the objects. We are not trying to change the address, but we just want to modify the contents. Is it possible to be done with call by value? It turns out it is possible. What we said in the review lecture, as long as the context object you get is pointing to some particular object you want to change, you can definitely change it by calling the corresponding mutative method. That's what you can do. All right? Why don't we take a look? Okay, that'll be the third example to conclude call by value. Guys, any questions so far? Are we okay? We still got one more example to see. So what you have to review later is to really see from these three examples, it really shows three different scenarios, which I'll try to summarize maybe after we have done the last example. Let's take a look, the last one. Okay? The last one here will be this method here. Okay? We still have the reference type parameter. This time, we are not trying to say maybe Q is reassigned to something else. What we do instead is to say, based on the object that's being pointed to by Q being the context objects, we want to modify its contents. It turns out it is possible. And whatever effects of changing the contents of the object is also going to be visible by the original parameter. That's a quick summary before we even see how it can work. Let's take a look. Okay? And after this particular call, you can see the parameter is simply P, right? Before the call, we got 3 and 4. After the call, it becomes 6 and 8. That's how we can do it. All right, let's trace to see what happened. The way we do call by value will just be the same as before, so it's always consistent. But depending on how we use it, it's going to have different effects. All right, let's take a look. All right, creating utility, we can skip. Now creating the point objects P, same as before. So P is pointing to a new point object over here, 3 and 4. 3 and 4. And then we also have some variable just for us to write assertions. So it's going to be a copy of P, reference of P before. All right, just alias. And we're now going to make this call over here. All right, let me just highlight it. And we ought to see how the call by value is going to have effects. So what we're going to do is, let me just, argument P versus parameter Q, right? So let me just make an arrow here. We ought to see how the call by value is going to have effects. All right? And let's now try to see. Call by value is going to make a copy of P and let Q store that copy of the address. P is over here. How do we make a copy of Q? In which case, Q is going to point to just the same objects, right? Let's do that. So Q is actually just going to point there. And for this particular one, you can definitely see the two remarks I made. The remark I made, it's just a copy of the address of parameter P. That's the same as before, all right? I'm not going to write it. All right, finally, let's take a look. What's going to happen here? We are not really trying to redirect the Q like the previous example. Instead, we just say Q dot move horizontally, Q dot move vertically. So we basically modify the object that's being pointed to by Q. At the same time, by the way, it's also being pointed to by P. And if you say, for example, here, move horizontally by 3, that means we're changing 3 to 6. Move vertically 4, changing from 4 into 8. So now, after the method call over here, if you try to say, first of all, P and reference before, P and reference before. They point still the same object. We have not really redirected P. That's good. So this one here and this one here, they're still pointing to the same object. So this will pass. And what about P here? P here is going to be referring to the object with 6 and 8. 6 and 8. Even though in the method itself, the way we change x and y is by using the alias q, which is a parameter. All right? That would be the easiest example I can use to really to distinguish between the three scenarios for call by value. Right? Are we okay with this? Any confusion? Right? Let me recap, and we might just move on. Call by value, scenario number 1. If the parameter is simply just a primitive, in which case, make a separate copy of the value. Whatever you do to the parameter is not going to impact the original arguments. Scenario number 2, if the parameter here is a reference type, in that case, call by value is just going to make an alias of the original arguments. And now there are two possible changes. Change number 1, if you just redirect the parameter into some other objects, it's not going to have any impact of the original argument P over here because you're just changing the address from one to another, right, for Q. Change number 2. Still, we got P, the arguments, and Q, the parameter. They are alias of each other when call by value first occur. But now you're trying to use inside the method call to say parameter using it as a context object to call mutate the method, to modify the contents. To 6, to 8, in that case, it's going to be visible outside this particular method call by using the parameter again, because it's still referring to the same objects, 6 and 8. All right, that's call by value. And we definitely need call by value in many scenarios. Even when we get to inheritance, we also need call by value to understand certain important stuff. We'll get there. All right, that's about it. What I want to talk about for call by value. Are you guys okay? Any question? All right, I presume everybody's happy. All right. Why don't we take a slightly earlier attendance today, and then after that we can move on to aggregation. Okay. If you guys can just get ready, all right, let's do it. Oh, sorry, that's not what I meant to do. Sorry about that. What I really meant to do was to start a class. And then some poll, and then whatever. All right, you guys can check in. As usual, if you got any issue now, please just come forward so you can put your attendance on the paper. Do it right away, please. I presume everybody's okay, right? I'll wait for maybe 20 more seconds. Good. Okay. Anyone still need more time to check in? Once I end it, done deal. All right? Okay, I want to make sure, okay? That's really cutting the line. Okay, come forward here and sign up right away. All right, done. Thank you. And take a 1 minute break, and then we'll resume aggregation composition. You as well? It's sorted by last name to find your last name. Thank you. Okay, good. Yeah, we'll start in just one moment. All right, let's resume. All right, so before the inheritance, which I'm pretty certain we can start on Wednesday, for sure. Before that, we're going to talk about aggregation and compositions. This will be mainly the topic for your lab number 3. However, I would say for the aggregation part, 99% should be no surprise. You'll know things, how to do things already. But I'll just go over more example and give you a little bit more hints about how to write dot notation, about class navigation. That's the main purpose for today, for aggregation. For composition, the main idea you want to learn about is something called copy constructor, which you will definitely get a chance to practice as well in lab number 3. But it's also a very straightforward idea. You just got to watch out for how you create objects inside the constructor. All right, we'll go one by one. And as I said, I'll really try to leave maybe about 10 minutes or so to go over the practice question with you about the written test 2 for tomorrow. Okay. All right, let's go over just some definition, right? A little bit dry, but I'll be quick. We have the notion between container and containee. You can think about for aggregation composition, we are talking about attributes of array type or linked list or collection type, right? In our case, array mostly. We got an idea about container and containee. So if you have some object, an object that contains others, that would be a container. If you got an object that's just being contained within another object, it's containee. It's pretty much like how we define caller and callee. Caller is calling somebody. Callee is being called by somebody else, right? Similar. But let's see, we'll see example. And there is one right away. Let's say here we say each course has a faculty member as its instructor. Right? In this case, let's look at this runtime structure, which should not be too strange to you. Let's say we have a course called EECS2030. That's a course objects. And then it contains a single attribute value called prof. And that one there actually points to a faculty objects. Let's say in this case, myself. Right? Now, for this particular link over here, it defines container and also containee. Okay? Let's see that right away. You can see for this particular link over here, it defines container and containee. So course will be container. Let me use a different color here just to be consistent. So here, the course itself will be the container. And the faculty over here will be the containee. Right? And of course, just like the caller and callee, we say a caller can be the callee at the same time. Of course, container can also be the containee at the same time. It depends on how you define the object structure. So focus on each link you're drawing. All right, let's see more bullet points. And we got course, we got faculty, and also another example would be that each student is registered in a list of courses, obviously. And how do we define container and containee? Let's see very quickly. Okay? You can see this student over here. Oh, sorry. Let's see student. Okay? The student here. Let's say Jim has a list of courses that he is enrolled in. One course is 2030. Another course is 3311. Obviously, we can, again, define container, containee. Let me use that. Let's say, for example, this particular link for Jin also defines container and containee. You can see this one here. The students is container, which contains the list of courses that the student is enrolled in. So this course over here is containee. Right? Obviously, you can see the same object over here can be both container or containee at the same time, depending on which link you're talking about. If you're talking about the prof link, then this object here will be container. If you talk about the courses that the student take, this link, then this course object will be the containee. It really depends, right? Hopefully that's sensible to you. All right, and so there's certain properties you want to just remember. They're also straightforward. Number one, we say containees may be shared by different instances of containers. For example, the same course may be taken by students and taught by another faculty. What do I mean? Let's take a look. It could be that let me use a slightly different example. Let's say this. It's not really drawn here, but let me draw that very quickly. Let's say I got another student over here. Let's say student 2. This is simply just another student. And the ID and also the courses, let's say the student is Tom. And let's say Tom is also taking several courses, okay, 0 and 1. Let's say for the first course Tom is taking is EECS2030. Over here. All right, so now let's take a look. I want you to pay attention to these two links. For Jin, over here, and for Tom, over here, you can see the second course that Jim is taking is 3311. The first course that Tom is taking is also 3311. So they share the same course. That's really the nature of so-called aggregation. So whenever we talk about aggregation, it's really about sharing. Aliasing. Right? In this case, again, for different student objects, they share just the same course, which makes sense, right? All of you guys are share the same course for 2030, section F. Right? Okay, and another property will be the containees may exist independently without their containers. So what does that mean? Obviously, let's say this object here represents 2030 section F, fall 2022. When we get to January, when this course is over, this may just be garbage collected because it's done. But are these two students going to be garbage collected as well? Not really, because they might still need to complete their degree. So that's why they might still exist. So getting rid of the container over here does not necessarily mean you have to get rid of the containees at the same time. Right? That's really what the slide is saying. However, when we talk about composition in the later half, it will be a little bit different. So whether you want to use composition or you want to use aggregation, it's completely up to what you need to model for your application. There's no right or wrong. You just need to choose the right model to implement. All right? Okay. And let's now see the only example. I think the best example to illustrate composition would be about file system. You know, when you guys maybe log into the prison lab and then with the remote lab and try to create some directories and files. That's indeed about composition. Okay? So we also got container and containee. For example, I created some dummy example here on my desktop. I'll show to you. Let me just minimize this. For example, you can see there is a folder over here. Right? You can see we got folder itself is a container which contains subfolder and also file. Right? And you can see this is just the directory structure. That simply makes sense, right? You guys have been doing this every day. However, there would be some property you have to watch out for the composition. So we would say, in the case of the student registration, it's more like aggregation because students might share the same course. And when the course is officially ended, the students are still there. But what about composition? So here we'd say each file, first of all, has exactly one parent directory, right? So what does that mean? You can see here, if I say file number 3, its parent directory is only 1, subfolder 2. What about subfolder 1? Its parent directory is only folder. It wouldn't be 2, right? That's one thing. And the second property is also very important. The containees may coexist with their containers. What does that mean? Let's say what I want to do now is if I want to delete this particular subfolder, which currently has a single containee, if I delete this one here, is this going to be deleted as well at the same time? Obviously, it will be, right? If you want to be convinced, I'll delete it. You can see both the container and containee, they're gone at the same time. So they must coexist at the same time. If you delete the container, containees should be gone as well. That's the essence for composition. You can think about every time you want to do deletion for composition, it has some cascading effects. All the containees must go as well. All right? All right, so it's only just some very brief, intuitive introduction about aggregation and composition. It's really about sharing versus not sharing, really. But we're going to go over examples, don't worry. Okay? It's always good to have some intuition before we go on to the example. Let's start with aggregation first, which is more straightforward. And for this course, it's not really about software design, but there will be some little bit design components to it. So you guys should you don't really have to draw design diagram, which you most likely will in 3311 in the third year. But at least you should know how to read design diagrams. So I'll tell you what you should know for the test and for the exam, which is kind of the minimum what you can expect. All right, so let me just talk about, excuse me, aggregation. So let me see. Okay, there we go. So course and students, they are the container in this case. Container. And this is also container. And we want to say the container actually contains a single object of type faculty. So you're saying that every course contains a single constructor, a single faculty, professor. And that professor there is called prof. Okay, I'll write it down here. That's how you interpret it. Each course contains a faculty called prof. So you can see the faculty here correspond to the faculty here. And also the prof over here correspond to the prof over here. And when I say a single, A correspond to the one here. Right? So the diagram itself tells you many things. Given the diagram, you can also easily think what would be the corresponding implementation in Java. That means in the course class, we have a reference type variable prof. You can see the course correspond to here. And the prof correspond to here. And what about 1? 1 means the prof is a single value. It's not even an array. And what about faculty? Faculty is simply just the type over here. And then we also got a faculty class. Are we okay with this? So there are 2 things you should know. Number 1, given this diagram, you should know what the code skeleton should be. Number 2, vice versa. Given this, you should be able to see what the diagram should look like. All right? And again, when you look at this line here, and there's a little diamond here you want to also watch out for. When the diamond actually is empty over here, this means aggregation, which means sharing is allowed. Later on, when we talk about composition, you will see that this diamond here is still there, but it will be solid, not empty. Right? That's something you can watch out for. All right, so that's the first case for the design. What about second case? In this case, we say the students contains multiple. We use a star for multiple. It contains multiple courses, and the name will just be courses. So what will be the corresponding Java implementation? You can see, let's see here. Students correspond to the student here. And also you can see the star here correspond to some array. Or you can use linked list, word list, or hash table, whatever. And what about the name of the containee? Courses. Courses over here. And what will be the interpretation? The interpretation will be, let me write it out again. Each student contains multiple, or an array of, or just say multiple. It has the concept of a collection. Multiple courses simply called courses. Right? You can see that's the name of the attributes over here. All right? Guys, are we okay? It's not too bad, right? Okay, that's the only design component you will need to learn for this course, aggregation. Okay, not too bad, right? Just remember about the direction of the arrow and also its empty diamond. Okay, you don't need to draw the diagram for this course, but you ought to know how to read them. Okay, to draw the diagram, you definitely may just do that in the third year, not now. Okay, let's now take a look. And it's really just a matter of tracing some example together with you. Okay, why don't we do at least one? And then I want to do also dedicate some more time for the exercise, for dot notation. I think that's more fun. Why don't we do at least one? I would say I'll do example number 1. Example number 2 over here will be very similar. In that case, I'm going to leave that to you as exercise. So here, I would say exercise to make sure you understand how the code works. And for exercise, for the example number 2, I want you to pay more attention to add teaching, for example. So this is about adding a containee. And programmatically, there should be no surprise. You have seen that since forever, since the beginning of this course. For example, we have seen add points, add entry, right, and etc. That's why you can definitely do this exercise rather straightforwardly. All right? That will be for your exercise. Let me just show you this one here very briefly, part of it, so you get a feel about what you're supposed to do. So what we do is, let's do that quickly. So we're going to create 2 courses, 2030, 3311. So why don't we do that? So I'm going to create 2 courses over here. So one here, and also one here. Okay? And 2030, 3311. EECS 2030, pointing to here, and also EECS 3311. And then the ID is going to be like that, right? The title over here, Advanced OOP. And for this one here, software design. Software design, right? Pretty straightforward. And let's see the first one, the next line. We create another faculty, we just create the first faculty object, prof. And will be myself, let's say. Let's say faculty over here, we're going to create the objects over here, and then prof. And the name would just be Jackie. Right? Also straightforward. And now I want you to know how to do these 2 lines. And again, it should be no surprise how to do it. Why don't we do it now? Context objects EECS2030 and set a prof to be the prof. I can refer you to this particular method over here, set prof, right? Since the context object is EECS2030, so this will be EECS2030. The prof will be, how about the prof? The prof will just be the prof over here. So that means EECS2030, the prof, is going to be pointing to this prof, right? That's how you start building the aggregation link. And why don't we do another one? Let's say I also teach 3311 at the same time. So I'm sharing, you can think about the 2 courses are sharing the same instructor. What about this line here? EECS3311 and also the same prof. So calling the same method here, and this now becomes EECS3311. So EECS3311 prof will now be, oh, I made a slight mistake. The title should be over here. Sorry about that. So the prof should be over here. So now this really entails sharing. What's really going on? The same prof is being shared as containee of 2030 and 3311. Okay, that's obvious. This one over here, and this one here. Okay, let me just make a remark over here. So this is indeed aggregation. Same prof shared by different courses. All right? The same containee is being shared by 2 different containers. And let's try to do a little bit more manipulation. What if I try to say this? Prof dot set name to be Jeff. Let's say we change the instructor for whatever reason. Okay? So prof over here dot set name. And set name is very, let me see, over here. That's a set name, right? If you set the name to be Jeff, so change from Jackie to Jeff. Now, if you try to run the assertion over here, assert true, let's try. EECS2030.getProf. EECS2030.getProf. Would it be the same prof as before? Indeed, the same link, right, for 3311. So this one should be obvious, right? And just make sure you're able to use the dot notation to trace where the object is. We spoke about it in the review lecture, right? And one more. What about the name? EECS2030.getProf.getName. This one should not be challenging either. EECS2030 is here, dot, going to the objects. GetProf is going to give you this particular prof. Dot, we get to these objects. GetName has been changed to Jeff. So that's why it's Jeff. Just make sure you're able to write complicated dot notation like this, right? And this part over here would just be very similar to what we just did. So I'm going to leave that also as exercise for you. All you got to do is to make sure you're able to trace the code on the paper and get yourself convinced why the corresponding assertions will actually pass or fail. Right? That's your exercise. So that's the first part about the aggregation, which is just about how you can use it and also trace the aggregation link. This is something that's not really new, so that's why I'm skipping a little bit. All right? Do you guys have any questions so far about this? Right? Nothing new, even though we're just telling you that it's actually called aggregation. All right? The second part will be a little bit more fun, which might be useful for your labs in general. The second part would be we want to have multiple classes in the context. And then we want to see how we can define the methods using the dot notation, considering there's aggregation links existing. Okay, let's see how we can do that. Let me go over some slides. All right, so that's the test case we just went over, right? And the second one over here is something that I'm going to leave to you for this will be the exercise I assigned to you. All right, so that's the exercise, slide number 15, right? It's pretty much similar. And what I want you to go over now is, let's say we got 3 classes in the context. Let's go over very quickly. And don't forget, you're supposed to read the diagram, right? Let's try to read it together. For example, students contains multiple courses called CS. So if I say student.cs, it's really referring to, for example, an array of courses. What about this link? This link here, well, remember the direction is really important. We're saying a faculty contains multiple courses being their teaching load. I just call it TE. So whenever you say faculty.TE, that's going to get you an array of courses, for example. Finally, what about this link? Again, direction is really important. Should be this way. Always look for the target with the name and also they call the multiplicity, the size of the aggregation link. A course has a single faculty called their prof. Right? That's something we just said. Right? So now we got 1, 2, and 3. 3 different links. Okay? I'll set up the context, and then we're going to do some fun exercise for you. Okay? We'll do it together. Let's say we got student class, we got course, we got faculty. And the basic layout is like this. In the student class, we got string ID. We got an array of courses called CS. Okay? In the course, we got title, we got prof, which is also single valued. And we got faculty here, we got the name, and also we got TE, an array of courses, the teaching load. And this will be the runtime structure you can have. Right? Something we just went over in the beginning. That's the setup. Okay? Feel free to refer back to this page when you study for the exercise. Now, the exercise goes as follows. I'm going to switch the context of the class one after another. We'll start with student first. And there are certain methods we would like to define. Only requires a one-line implementation. But I want you guys to think about very clearly about, based on the design diagram or the code, how are we supposed to write a dot notation to get a return value? All right, I'll give you some example. So we start with the student class. If we are now in the context of the student class, we want to define 1, 2, and 3. 3 methods, right? Again, so get ID, get title, and get name. These three methods are going to be defined in the context of the student class. Okay? We want to see how to define them. Let me start with the easiest one. How do we get the student's ID? Well, you can just return the ID, the attributes, right? We're not in this context. ID is already directly available, right? Always remember the starting point of the dot notation is the attributes that are there in the same class, okay? So here we can simply say return this dot ID. You can think about this is really about student class. And when you say ID, it's as if you go from students, let me show you here. If you see the students over here, and then when you say ID, it's going to traverse this link and get to that particular string, right? So that's the first one. Let's see the second one. I want to get the title of the student's ith course, for example. If I give you one example call here. Let's say we got, let's say the student's gym, which is S dot get title. Let's say 1. What does that mean? Diagrammatically, S is referring to the students. And then the student is taking 2 courses. Go to index 1, get to that particular course, and get its title. That's how it is supposed to work. But how do you define the implementation here? What should I return? That's your exercise. Think about it for a few moments. And I would like that one-line implementation from you. What should I return? This one is not too bad. The third one may be a little bit tricky. Any volunteer? Anyone? Marcus, please. Yep. But if you only return CSI, that's only the course object, right? But how do you get a title? So what you just mentioned here, let's also help everybody. If you say S dot get courses, let's say I, in this case 1, that one can only give you this object here. But what we want is a title. So maybe something further.
Yeah, and then you're going to have to use dot get title.
Yes.
Not there, and that's when you return the title.
Yes, exactly, right? Good, pretty good. Let's write it down. So this one here, you're going to say return. Let's say this dot courses array, right? Remember that's in attributes. Add index I dot get title. Okay, let's now review what's happening here. This will be whatever student object it is. CS will be referring to this array. Index I, for example, 1, index 1 is going to refer to some course objects, and then we want to get title. In that case, get a title, which will be software design. Are we okay with this? Not too bad, right? What about this one? This one's interesting. Given the students, if I say, for example, S dot get name. By the way, if I say S dot get name, I don't want the gym. That'll be too easy. What I want is If I say get name, and notice that there is a parameter over there. Let's say get name, maybe 1. What does that really mean? That means for this student here, go to the course of index 1, which is over here. For that one there, get to their instructor and find their name. That's what it is supposed to do. And now, how do we write that one line implementation? Pretty long, but how do you write it? You almost volunteer. Do you want to tell us? Yes, please. Okay, CSI, yeah, just give me a moment. Let me write it down as you tell me. I would suggest always start with this. Oh, yeah, sure. This dot CS, and then? Of I, exactly. We need to get to the index. Well, let's say CSI might only lead you to just the course, right? But we want to get the prof's name for that course. Yeah, so we assume that for every private method, you actually got some public accessor. So maybe once you get to the course, you want to say get prof. Would that be it? The name of the prof. Good. All right. Let me write it down. Very good. Thank you. So once you get to the course, you got to say get prof. And once you get a prof, you're going to say dot get name. That'll be the one-line implementation. Let's see. This will be the student object that we start with. CS will be the array. I will be this particular one, which is referring to this course that the student is taking. Get a prof is going to refer to this link. That'll be the prof faculty object, and then get name. In that case, Jonathan. All right? Are we okay? So this is when the context of the method is the student class. Let's now switch the context. Switching the context means the attributes you may start with will be different because we're talking about different class, right? Okay. Let's say now we have the context being just the course, not student anymore. You definitely cannot start with CS. There's no CS attributes in course, all right? So we're going to define 1, 2, and 3. The first one, extremely easy. Let me do it. You can just return. How do I get the title of the course? If the context object is course, get a title, just get title. Return title. This dot title. All right, that one's easy. Okay, what about this? Get name. I want to get the name of the instructor of the course. You can see there's no need to pass any parameter over here because for every course, we're assuming that there's only a single instructor. What should I write? Anybody? Ferris, please.
This get from the get name.
Absolutely. Yes, you get it. Yep. Yeah, you want to get a feel about dot notation. Dot notation just depends on the starting point for the context. Everything else will be done accordingly. So it's going to be return this dot get prof, or just this dot prof, that's okay too. Dot get name. Okay, let's just review that. This will be the course. Get prof is going to get to whatever prof it is. Let's say faculty here. Get name. Get name, Jackie. All right, final one. Okay, so get title, what does that mean? For this course, find its instructor and then go to the ith course that's being taught by that particular instructor. For example, let's say this. let's say software design, all right? And if I say, this one is a bit interesting. So if I say EECS 3311 dot get title. And then let's say, why don't I say 0? And what does that mean? That means this course over here get to its prof somehow, it's Jonathan. And for this instructor here, in general, it simply has an array of courses that's being taught by him. But in this case, we just got 1. That's OK. But the index we want to get is 0. In that case, get to that particular course and get its title. In this case, software design. Of course, if I, let's say hypothetically, if that instructor also teach, let's say this course over here, and if I put 1 over here, then the title in this case will be advanced OOP differently, right? It depends on the runtime structure. But now, how do we define that in general over here? What should I put? What should I return? Yes, please. Let me write it down as you say, just to save time. Yes. Return. Let's say we start with this, if you don't mind.
So return get prof.
Get prof. Yeah, let me do that.
Get title with the parameter I.
Okay, once you get prof, right? Let's say prof is, let's say prof is here. You don't have get title. Maybe you really meant get the teaching. Yeah, because in the faculty here, you can see for faculty, you don't have title. You only got TE.
Yeah, I might get, we got to access the faculty class, right? Because we're the array of,
Okay, so did you really mean you want to say get title here?
yeah.
Okay, and then, okay, let's try that first, please. Go ahead, and then?
With the parameter I.
And then, okay, parameter I, okay. Okay, okay. I think I know what you mean. Let me write it down. I think that's good.
Or maybe.
No.
I guess don't get course.
Yeah, so here, you know what? We wouldn't want to guess because once you get prof, you're basically now in the faculty class, which has this definition. You want to be precise about which attribute you want to call. Which attributes? Do you want to call the name or the TE or something else? .te, yes. Yeah, that's why when you say get title, that's not exactly right. There's no get title, right? Yeah, here. Okay. Get TE. And then that one will be an array, obviously. And then you want to get to I, which corresponds to this. That one there should really get you back to the course. And then get title, yes. Would that be it? That's it? Okay, good. Thank you. That's pretty much right. Yes, just in the beginning, you want to be more precise about attributes to be called. It depends on the class definition. Let's try this one here. This will be the starting point course. Get prof is going to get to that particular prof faculty objects. And then here we only got 2 choices, either get name or get TE. In this case, we want to get a TE. If you get a TE, it's going to be this particular array. In general, it can be arbitrarily long. And then we want to get to this particular index I, which will be 0. Get there, and then you get to the course. Once you get to the course, you want to get its title. Over here, advanced OOP. Okay? Guys, are we okay? All right? The dot notation is actually not too bad as long as you know where the context is. All right? Why don't we do, yeah, question, yes.
Okay, so when we use this .get prof, you say we go into the faculty
Objects. Yes.
So do we need to use .get TE or can we just use .te of I?
It's a very good question. Okay. You know what? I think for this one here, you know what? Marcus has a very good question. I would suggest I delay this question here. I can do a little bit better presentation just to strengthen. Dot TE or dot get TE. Okay. Given that TE over here is actually private, right? Let me answer this question in the beginning of Wednesday to actually clarify. That one requires a little bit more of extra illustration, which we can get to on Wednesday, okay? I'll definitely get there. It's actually a very important question, Wednesday. Okay? Guys, apart from this, any other questions? Okay, all right, the final one over here, okay? And we have, again, switched the context to just faculty, right? And then we're going to get, what about the name of the instructor? Well, just get name. That's easy. And the final one. If you say get title and then I, get the instructor's I teaching course and get its title, right? This one here, let's say the faculty is over here. And if I want to get to the teaching course of index 0 and get its title, that one is not too bad, right? It's less trickier than what we had before. This one here, and Ferris, why don't you let us know the answer? Yep. Thank you. The get TE or TE. But of course, I'll talk about the difference on Wednesday. Right? Let's say get TE. And then add index I dot get title. Thank you. Yeah, for example, let's say we are here. And then if you say get title, let's say 0. In that case, you will end up giving the title of the 0th teaching course, which will be Advanced OOP. Right, guys, it's really important for you to see how to use a dot notation depending on what the context class is. That's the key. All right? And that's about it. I want to talk about aggregation. Okay? And the next one will just be about composition. I think I just got about 10 minutes left. As I promised, I should really talk a little bit about written test too. Right? That's something also very important. Why don't we do that? So the plan for Wednesday will be, I'll start with that detailed discussion about whether you should say .te or get te. There is a minor subtlety over there about the attribute being private or not. So I'll talk about it in the beginning. And then I will also finish the last part, which is about the composition. That one there will just involve certain example and also define what a copy constructor is. And after we have done that, hopefully within 20 minutes, and we're done with the lecture, and you're fully ready to do lab number 3. But you're already ready. Just get into lab 3. You might just be able to do it. The slide is there. Feel free to study ahead. And after this, we're going to dive into inheritance for this course. I think that's really the highlight for this course. I will cover that very systematically and thoroughly with you guys. It's really important to understand inheritance. Okay, we'll get there. All right, so now let's worry a little bit more about your written test. Tomorrow, okay? And, okay, I'll talk about this on Wednesday. All right, so I got 7 questions for you guys. If you have already tried, good for you. If you haven't, that's okay. So I would suggest just get an idea now, and then you still may want to do it from scratch today and tomorrow, okay? Let's talk about it. Okay. I think question 1 and also question 2, they are more about the conceptual assessment about how you understood the catch or specify requirements. Okay, let's take a look at the first one. So that's the cost stack that we actually talked about in the class, right? Make sure you review that. And basically we say that this is the method that actually throws some exception. Oh, by the way, so here, we actually got some cost stack over here. We started with the main, and then with B.MB and then A.MA. So that's a cost stack. So we, beg your pardon. How about this? So we start with the tester dot main, which is this method here, which calls B.MB, which in turn calls A.MA. So that's a cost stack, right? Make sure you understand about the cost stack. It's so important, especially we talk about caller and callee in the beginning. That's something you definitely want to review. And this is what happened. Let's say A.MA at the top of the stack throws some exception that must be handled. And we said before, normally, for the method that actually got the method originated, should really just do the specify option, normally. And because it throws and specify, and then we're actually going to check to see whether b.mb is going to handle that. In this case, because of the arrow, it says that it's not going to handle it. That's why you also propagate the exception. Every time you propagate, because b.mb specifies it. Right? And then we go to tester.main. And that one there, actually, it goes back to itself. That means it's not really propagated to the console. That means it's handled over there. So now, how many methods have specified the exception? 2, right? It's mainly this one here and this one here. So 2. That'll be the answer, all right? And of course, obvious follow-up question you can make it for yourself. What if the diagrams show a little bit differently? Let's say tester.main also is not trying to handle that. So that means we're going to propagate it to the console. In that case, the answer would be 3 rather than 2. All right? Good. The second one. All right? That was interesting. Let's read it together. I'll make it larger. At a runtime call stack, right? Like a stack. If a method implements a try and catch block to handle a negative value exception that may be thrown from its callee, then this method's caller is still obliged to either catch or specify that negative value exception. Sounds a bit confusing, right? I agree. So that means you have to visualize what's really happening here. I'll help you with that, okay? Let's say this. Let's have a call stack. Oh, again, hard to draw. There we go. That's a call stack. Why don't we say we got main method over here, and also let's say we got method 1, we got method 2, we got method 3, we got method 4, right? Let's try to understand that. And let's say M4 is the original place to throw this particular exception. Let's say this one here throws negative value exception. That means we are now going to look for the first one that's actually going to catch it. Whenever the caller actually specifies it, we're going to propagate it further. Agree? Okay. Let's try to visualize what the question is saying. If a method implements a try and catch block to handle this, let's say, for example, let's say M2. This one here implements a try and catch block. A try and catch block. And to be more precise, that means somehow it's going to say try, and because M2 is the caller of M3. Agree? Okay, so somehow M2 is making this call, M3. Of course, with some context objects. So let's make sure this is very clear to you. M3 over here is the callee, so the callee of M2. M1 over here is the caller of M2, right? That's really the thing you want to visualize. Okay, let's say we implement a try and catch block, then this method's caller is still obliged to either catch or specify that exception. Okay? Is this true or false? What it is saying is, if M2 already tried to catch, let me just be more precise here, the negative value exception. over here. Okay, this one here. Let's say this is M2, where we try and catch the exception. Now the question is, the caller is M1. M1 is the caller of M2. Does M1 still have to satisfy the try and catch requirements? That's really the question. Let me summarize, recap, and then you can tell me true or false. Okay, let's start with from the beginning. Let me recap. We got a call stack. Main calls M1, M1 calls M2, M2 calls M3, M3 calls M4. M4 throws that particular exception. And then we assume that, let's say, M2 is the first one that actually try to implement a try and catch block to handle the exception. If that exception can be caught at this level, is the further caller at the stack, meaning that everything that's below M2, are they still obliged to be subject to the try and catch requirements? True or false? False. Should be false, okay? All right, guys, it should be false because once the exception has been handled, no other methods or callers should really handle that. If somehow M2 still try to specify the exception, of course, its caller will still have to be subject to the requirements. That's really the key. All right? You will see something like this tomorrow. So the best way to really try to decide the answer is to visualize what's being asked over here. All right? Hopefully that makes sense. All right? I still got 2 minutes. I'll do as much as I can. All right? Okay, so I think Q3, Q4, Q5 are a very similar line of thought. I'll do one of them. So to tell you how you should really think of it. Q6 is just about assertion of equality, which we also spoke very much about. I think it should be okay. And Q7 is about the short circuit effects that we review. Right? So I think these Q6 and Q7, I'll leave them to you. If you got any trouble, please let me know. You still got office hour today and tomorrow. Okay? I want to do one of them with you. And I think that'll be good enough. Okay, let's do Q3. It will also be a very typical question you might be asked tomorrow. Okay, so here we got some tester. And the tester can either be a console tester using print line, or it could be a JUnit tester using assertion. Either way, right? We cover both in the lecture. And the maximum value is 3, and then let's say this one here. And what you're being asked is, let's say the increment method that we are trying to test was implemented correctly. So you want to be very careful. Whenever I give you the tester there, you want to know whether or not the implementation was correct. If it is incorrect, you will have to judge a little bit differently. All right? So let's try to look at this here. So we initialize the counter, and then this one here, just check its current value, which should be 0. And then we do the try block over here. Because we assume that the increment method was implemented correctly. So this one will go from 0 to 1 without throwing any exception unexpectedly. Also so here, this will be from 0 to 1, and 1 to 2, and 2 to 3. So far, since we assumed the implementation was correct, no surprise. Okay? And then we're going to print out the current value. That should be 3. And we're going to do some further check. And you got to review your lecture why we would need nested try and catch for the console tester. But for the JUnit test, we don't really need to nest them. We explain them in detail in the lecture. All right? So now, if we try this line here, in this line here, we basically intend to go from 3 to 4. A correct implementation should throw some exception. Agree? In that case, we should definitely just go to over here and say that should be a success. So this is really your answer. Of course, the way to do that in E-class is by dragging and dropping into the line into the boxes. And make sure you practice that. All right? And of course, if you go to the next two variants over there, you actually assume the implementation may be incorrect in different ways. So that's also something we spoke about in the class. You ought to be able to trace about incorrect implementation. At some point, the execution flow will get to somewhere which will say error. Right? So that will be the essence for this question. You'll definitely see some tomorrow. All right? Guys, any question for me? I know I'm over time, but if you guys got any question here, either ask me now or talk to me later. Okay? All right, happy Halloween. Enjoy your time, and I'll see you tomorrow in the test.